This is tutorial 6A, question 0A, part B. In this question, we're asked to interpret what is B0 to B15 for n equals to 16. What is a square matrix W bar? And you can see the discussions here in slide 6.1, page 11. So we're asked, what are the elements of W bar and why do we need B0 to B15 for n equals to 16? And is there such thing as B-1, B-2 or B16, B17? Let's now answer the questions using the slides of our lecture notes. Let's first go to page 8 of our slide. We see that in this particular example, B0, B1, B2 up to Bn-1s are column vectors and they are complex value with n elements. In particular, if you view this as a complex number, the elements have radius 1 but with different phases. And for B1, it basically have a rotating vector that completes one complete revolution in n samples, and B2 will complete 2 revolutions in n samples. So the index k here represents the harmonics. The higher the value, the faster it is rotating. So now I plot B1 in 3-dimensional. Here B1, the first element is 1, the second element is also 1 but now phase shifted by 2 pi over n. The third element is with radius 1 but now shifted 2 pi over n times 2. So you can actually see the phasor moving. This axis is the real axis. This value is 1, this value is 0, and somewhere along here will be -1. This is the real axis, and on the vertical line, now I draw in green, is the imaginary axis, and now I draw in red. Is coming out is time, discrete time. You'll see that the phasor, the first point, starts from here. So this particular point is x0, this point is x1, this point is x2. It is a phasor that only moves in discrete time. So that blue line doesn't exist. We're just drawing it to show the trajectory. In only discrete time is on the dots, and it is rotating anti-clockwise, and after n samples it will go back directly to the same position as the first point. So in this particular example, n equals to 8. Let's count. 0, 1, 2, 3, 4, 5, 6, 7. On the 8th point is exactly the same as the 0 point. So in this example, big N is equals to 8, and at each sample we are moving by 2 pi divided by 8, which is pi divided by 4, which is 45 degrees. So you can see also that this angle here, theta, is 45 degrees. So here, theta, this is x of 0, this is x of 1. So let's say this is x of 0, this is x of 1. Now let's think of what is B2. B2, as you know, it is a complex exponential rotating 2 times faster than B1. So how do I know? You look at this. In 8 samples, he rotates 1 round. In 8 samples, he rotates 2 rounds. That's one way to look at it. The other way to look at it is in every 1 sample, he jumps by 90 degrees compared to the previous guy, which jumps by 45 degrees. What about B3? B3 is even faster. In 8 samples, he completes 3 rounds. In 1 sample, he jumps by 45 degrees times 3. So now we know what is B1, B2, B3. What do? We put them into the matrix W hat. The columns of W hat are B0, B1, B2s. So now we know what is the elements of W hat. The second part of the question says, why do we only need B0 to B15? What about B16, B17? You can try to calculate B16 and you realize that B16 has the same value as B0. B17 has the value of B1. What about B minus 1? B minus 1 has the same value as B15. B minus 2, same value as B14. What you need to do is simply to plug it in into this equation over here, where you are changing k. You set k equals to 0 versus k equals to 16. Let's see what happened. 2 pi over n k versus 2 pi over n k plus 16, and let n equals to 16 in this example. This is 2 pi over n k plus 2 pi 16 over 16. What is this? Plus 2 pi. 2 pi over n k. Since we are doing exponential of this value, exponential of 2 pi over n k, the plus becomes a dot. 2 pi. What is this? 1. And hence we realize that once you go above n, then we can decompose this 2 pi over n k plus n into this form, and it will reduce into 1. And hence, that's why B0 to Bn minus 1 is the same as Bn to B2n minus 1. So that answers the question here. Thank you.